In this presentation we are going to look at the floor and ceiling function. So the floor function of x, which we will denote with this symbol here, it is a square bracket missing the top component, is the largest integer not greater than x. Okay, so the largest integer not greater than x. Given any real number, the floor function is unique integer n, such that n is less than or equal to x. Okay, we're not really that particularly concerned about the rest of that expression. The ceiling component, the ceiling function of x, which we'll denote there, again, this time in the square brackets the bottom part is missing, is the smallest integer not less than x. So given any real number x, the ceiling function is a unique integer n, such that x is less than or equal to n. So n is an integer. So floor and ceiling functions, the outcomes are integers. So the floor function of x is, okay, sorry, this is what I want to look at here. This is a number line. So I'm just going to draw a straight line here. And that's not a straight line. Give me another go there. So there we go. Now I'm going to pick, this is going to be the 0 point, make this 1, 2, and I'm going to go -1 and -2 here. So this is the number line, those are all integers. What I'm going to do is pick out 2 points. I'm going to pick, let's say, 1.3. Well, the floor function of 1.3 is 1. It's the integer that precedes it on the number line. And the ceiling function of 1.3 is 2. It's the integer that comes next in the number line. So, okay. Now, let's go to the other end here. Let's suppose we're dealing with -1.5, let's say. Now, this is, be very careful here. And it's actually a good idea to visualize the number line when you're doing these. The integer that precedes it in the number line is -2, and the integer that comes after it is -1. So that could be a bit very counterintuitive. So let's write that out. The floor function of 1.5 is -2. The ceiling function of -1.5 is -1. Likewise over here, the floor function of 1.3 is simply 1. The ceiling function of 1.3 is 2. It's actually also usually on the negative side of the number line that we run into problems. Okay. Now, if x is an integer, then the floor function and the ceiling function both take the value of x. So if x is an integer, x equals the floor function of x equals the ceiling function of x. Now, a useful sort of, another extra sort of component that is brought into consideration when we're doing these type of problems is the fractional part of a number x. It's the difference of the value of x and the floor function. So we write it like this, x minus the floor function of x. Okay, let's look at some examples here. So 2.4, the floor function of that is 2. The ceiling, 3. And the fractional part, 2.4 minus 2, that is 0.4. The floor function of -5.4, just remember the number line, it's -6. And in this case, the ceiling is -5. Now, let's do the fractional component here again. You might be surprised by this result. -5.4 minus -6. The minuses cancel out, so actually what we're left with is +6, essentially. Let's just rub that out there. So it actually becomes +6, and the answer is therefore 0.6. So the fractional parts can be, again, for negative numbers can be tricky. This x is an integer, so 1, and the fractional part is 0. 0 is an integer, so 0, 0, and the fractional part is 0. Again, -4, that's an integer, so -4, -4, and 0. Pi, 3.1415, let's say. The floor function of that is 3, Ceiling function that is 4. And the fractional component is 1.1415. We're dealing with positive numbers. It's essentially whatever comes after the decimal place. The minus pi, minus 3.1415. Again, what integer precedes that on the number line? Minus 4. What integer comes after on the number line? Minus 3. And again, watch out for that the double negative problem. So this is minus 3.1415 plus 4 minus 4. That works out to be 0.858. I'm just reading it off a computer. So it's I'm not going to round it down. 0.8584. Okay. So that's including rounding error. Or not including rounding error. So that is the answer there. Those are the answers there. Again, you can pause it if you want to make a note of them there. And that ends our presentation.